Okay, in this video, we are going to explain the definition and, of course, branches of physics. First of all, what is the definition of physics? Physics can be defined as the branch of science that deals with the study of matter, as has been highlighted here, and energy, and the relationship between their properties. When you study matter as well as energy and the relationship between their property, what you are doing basically is the study of physics and the relationship as well between them. Is that okay? So let's move on. Let's move now. Let's talk about the branches of physics. The first one out of them all will be mechanics. As you can see in this place, mechanics. What is mechanics? One of the major important branches of physics is mechanics, which has been defined as the branch of physics that deals with the motion of objects. Anything that moves can be related to mechanics in physics and the forces that cause or change their motion. We are not just talking about object moving, we are also dealing with what is interested and what is responsible for causing their motion. You could see the movement of vehicles in this place, of course, movement of vehicles, as well as a rocket, pulley system, many other things are associated with what? Physics, and many more. Now, what are the areas of applications of mechanics? We have transportation, construction, sports, and robotics. Of course, robots have moving parts. We have construction, we have transportation, and sports. So, what are the devices that are associated or instruments? We have lever, pulley, speedometer, we have rockets, we have machines that can move, and many more. Then the next branch will be thermodynamics, which is also talking about heat. You can also call it heat, that is heat in motion. Now, the branch of physics that deals with heat, temperature, and the changes of energy from one form to another is regarded as thermodynamics. Of course, the principle of design of refrigerator, deep freezers, air conditioning system, all thermometer, calorimeter, heat engines, these are related to the branch of physics we call thermodynamics. From the word thermo, temperature is involved with heat, dynamics, motion, power, changing position. What are the applications? The generation of power is connected to thermodynamics. We also have refrigeration, like I've explained, air conditioning system, and cooking, of course, because heat is required too. So as for that, I think we'll move to the next branch of physics, which should be um, optics or light. Branch of physics that deals with the behavior and properties of light. Behavior and properties of light. This is telling us how light behaves. That is optics and the properties of such what? Light. Of course, application, vision, and eye care. We also have communication, that is optics communication. We have photography. Without light, photography is not possible. We have optical instruments like a microscope, telescope, spectroscope, camera, and many of them. They are all related to light. Okay, let's go to the next branch, which is acoustics. In other words, sound. Definition. The branch of physics that deals with sound waves, their production, propagation, and effects. How can sound be produced? How can sound be propagated? That is to say, how can it be transmitted from one point to another? And number three, what is the effect of such sound? The design and the working principle behind microphone used for daily communication, loudspeakers, stethoscopes, and ultrasound machines, and even musical instruments all depend or connected to the branch of physics known as acoustics sound. What are the areas of application? Music and entertainment, communication like phone communication, then medical diagnosis, which is the ultrasound machine, and sound engineering. The principle of soundproof, all these things are connected to acoustics. We move to the next branch of physics, which is electricity and magnetism. I want to submit to you that this is one of the important branches of physics when it comes to um, smart devices and technology and what have you. The branch of physics that deals with electric charges, electric current, magnetic field, and their effects. You see transformer here, you see electric motor here, you see generator here, you see electric bulb here, and many of them. Now, what are the areas of application of electricity and magnetism? Power generation. Of course, with the help of electricity and magnetism, power can be generated. That is electric power mainly. We have the principle of electric working principle of electric motors. We have magnetic storage. We have telecommunication. This is very important. Your satellite communication, your cellular communication, and other communication depends solely on the interaction between electric field and the magnetic field. Without this, it will be very, very impossible to send electric communication signal from one part to another. The world of communication will not be possible. It will still remain indigenous and never modern. Okay, the next aspect we want to deal with is electronics. Sometimes electronics can be a subset of electricity, but it is unique. That's why we're bringing it here. The branch of physics that deals with the behavior and control of electrons and the design of electronic circuit and devices. This is where artificial intelligence lies. Without this, artificial intelligence will not be possible. Control systems cannot be possible. Smart devices cannot be possible and what have you. We have transistor, we have diode here, we have integrated circuit, we have oscilloscope, we have triac, we have diac, we have thyristors, and what have you. They all depends on electronic what devices that can help in making our world fast, improving technology, in technology rather. What are the areas of application? We have computer, we have telecommunication, we have, of course, consumer electronics, those electronics gadgets we use at home, be it my laptop, be it cellular phone, be it television, and some of them. Now you see it, automation and control. This is where robotics comes into play. This is where artificial intelligence comes into play. You see, electronics is very important. Let's move to the next branch of physics, which is atomic physics. Now, atomic physics is a branch of physics that deals with the structure and behavior of atoms and the interaction of electrons with matter. Atomic physics from the word atom with three fundamental particles mainly, which are proton, electron, and neutron. How they behave and how they interact with matter is one what we call atomic physics, the study of that. Now, applications we have spectroscopy, we have atomic clocks, we have semiconductors, technology, we have medical imaging. Now, devices associated with that are atomic spectrometer, electron microscope used in viewing very tiny and microscopic objects, laser system. That is the principle of laser light propagation and what it can be used to obtain, surgery, and what have you. So these are very important aspects and branch of physics that we cannot but discuss here. Now, nuclear physics. Nuclear physics is very related to atomic physics, while atomic physics studies the entire atom and what it can be used for. Nuclear physics concentrates its emphasis on the nucleus. That is to say, we are dealing with the proton and the neutrons predominantly, and how it can be of help into human existence. The branch of physics that deals with the structure and the reaction of atomic nuclei, including radioactivity and nuclear energy. You get it? So it's mainly about what? Radioactivity. Then what are the applications? We have nuclear power, we have medical treatment, that's radiotherapy, we have nuclear medicine, we have space exploration. Devices are giga counter, radio radiation detector, and particle accelerator. These are very important devices that helps in making life better. And nuclear physics is very important branch of physics. And the last but not the least, because there are many, is astrophysics, that is space physics. This is the branch of physics that applies the principle of physics to the study of celestial objects like the sun, the moon, the stars, and the other planets, and phenomena in space. Without the help of astrophysics, we would not know the behavior of space, and space exploration might not be very, very possible. Now, the devices that are associated with such branch of physics are space telescope. We have satellites. Of course, satellites can do a lot, can be used for military surveillance, can be used for scientific research, it can be used for global positioning system, it can be used for communication, it can be used for security surveillance, and many other things. We have radio telescope and we have spectrograph. These are branches of physics in a glance. Now, there are other branches which we call this, which we call quantum physics. This has to do with the behavior of tiny particles, not macro particles like mechanics. That's why mechanics is under classical physics. We have classical physics and quantum physics. Classical physics, which I had discussed earlier, are dealing with major or big elements, big devices, big particles. But for quantum physics, we are dealing with the behavior, the motion, the interaction within between tiny particles. So that's all about this today. Have a nice time with yourself.